So, have you ever wondered why the impact of expensive leadership training seems to just, well, fade away? It turns out it's often not a failure of the training itself, but a predictable outcome based on how our brains are wired. In this explainer, we're going to break down the cognitive science behind why that training decay happens and what it really takes to make new behaviors stick. Here's how we're going to tackle this. First, we'll define the problem itself. Then, we'll dive into three key cognitive mechanisms: the forgetting curve, context-dependent recall, and habit regression. After that, we'll look at reinforcement as the countermeasure, and then we'll wrap up by exploring what this all means for investment decisions. Okay, so let's jump right in and define the problem. The fact that training often fails to create lasting change isn't some random organizational fluke. It's actually a predictable, scientifically observable outcome. And when you look at the data, it's pretty eye-opening. Just look at this number from the Harvard Business Review. Only 12% of employees actually apply the skills they learn in training programs to their day-to-day work. That's not just a small gap, right? It's a huge disconnect between what's learned and what's actually done. And it gets even more stark when you look at this number from McKinsey. A whopping 87% of training content is forgotten within a single month. What this really tells us is that without some kind of reinforcement system, the vast majority of the investment in training is just lost, almost immediately. So this leads us to the first cognitive mechanism we need to understand. You see, the decay of memory isn't random at all. It follows a very well-established scientific pattern. It's called the forgetting curve. This idea has been around for a long time. It was first described by the psychologist Hermann Ebbinghaus. And his forgetting curve shows that we forget new information at an exponential rate right after we learn it. That is, unless we make a deliberate effort to retain it. It's a fundamental principle of how human memory works. And this bar chart here gives you a clear picture of that forgetting curve in action. The first bar shows that after just one day, retention can drop to 50%. The second bar shows that a week later, we're down to just a quarter of what was learned. And as the third bar shows, after 30 days, only about 13% of that information is left. It's a rapid and steep decline without reinforcement. All right, let's move on to the next cognitive barrier. It's called context-dependent recall failure. And it's a huge piece of the puzzle because it explains why skills we learn in a classroom so often fail to show up when we're actually at work. This slide shows the critical difference. On the left, you've got the training environment. Think of it as having a low cognitive load, focusing on abstract ideas and filled with classroom cues. But on the right, you have the operational environment. This is where you have a high cognitive load, you're making concrete decisions, and you're surrounded by real workflow cues. The problem is, our brains encode information with its environmental cues. So when those cues are gone, recall often fails. The third mechanism at play here is habit regression. During our daily operations, our brains are hardwired to save energy, and they do that by defaulting to established automatic behaviors. This makes it incredibly tough for brand new skills to actually take root. This whole process is driven by something called the habit loop. As you can see here, it starts with a cue. That's some kind of trigger in the work environment. That cue then kicks off the routine, which is the automatic established behavior. And finally, there's a reward, a familiar outcome that reinforces the whole loop, making that old habit even stronger. A new skill from a training course really struggles to compete with this powerful cycle. And this tendency to revert to our old automatic patterns, well, it has a name: execution drift. It's that gradual, often unconscious deviation from the standards we're supposed to be following, all driven by the powerful pull of our ingrained habits. So if we know that training decay is predictable, what's the solution? Well, the answer lies in continuous reinforcement. It acts as a direct cognitive countermeasure to all the forces we've just talked about. This diagram gives us a really clear visual framework for this. The box in the middle labeled drift represents that central problem we've been discussing, influenced by those cognitive forces. But the critical part is the corrective loop shown by the arrows. An execution system provides continuous reinforcement, and that creates a force that counteracts the drift, restoring behavioral alignment. It shows why you need to engineer a system, not just host an event. The underlying research for this analysis is recorded in the following publications: DOI 10.5281/Zenodo 17394116, DOI 10.5281/Zenodo 1742556, ORCID 000004 66256634. Okay, so let's wrap this up by connecting all of this cognitive science back to its strategic consequences.
Because understanding these mechanisms really should change how organizations think about investing in leadership development. It really requires 4 critical shifts in investment strategy. First, moving from one-off episodic training events to continuous reinforcement systems. Second, shifting from measuring course completion to measuring actual behavioral consistency. The third shift is funding the execution infrastructure, not just the course content. And finally, organizations have to move from just accepting drift as inevitable to actually engineering systems that are designed to prevent it. And all of this brings us to a crucial reframing of the whole issue. You see, the critical question for organizations is no longer how do we train our leaders? The real question is how do we build the systems that ensure they execute consistently, day in and day out in the actual flow of work? Published by the Leadership Execution Institute.